question 3.1, we are told to consider the following geometric series. This is the geometric series given, and the first question says that for which values of x will the series converge? So whenever they ask you this, for which values of x, or for which values of r, whatever, will the series converge, you know convergence is determined by this. R must lie between -1 and 1. So this determines convergence of a series, a geometric series rather. So for us to prove this convergence, we must find R in this geometric series. So to find R, we know it's going to be R equals to term number 2 divided by term number 1 is equal to term number 3 divided by term number 2. So this is term number 1, this is term number 2, this is term number 3, right? So R is equals to, our term number 2, it's 5 into 3x plus 1 all squared. Our term number 1, it's 5 into 3x plus 1 equals to, so the terms must be, the ratios must be equal for us to confirm that that is actually the ratio we're looking for. So here it's to the power 3 over 5 into 3x plus 1 to the power 2. So if you can see here, this is similar to this, so they divide out, and these are similar only because this one is squared and this one is 1. So you'll remain with 3x plus 1. So this is going to be your R in both sides. So it's going to be 3x plus 1. So that is your ratio. So you're going to put your ratio inside this convergence here. So you're going to say my convergence must lie between -1 and 1. But what is my R? It's 3x plus 1. Lie between -1 and 1. -1 and 1. So for us to solve here, you must transpose this one both sides. So you transpose it that side, you also transpose it that side. So we're going to have -1 because they changed the sign from positive to negative, less than 3x, less than, so it's going to be the 1, which is this one here, and then -1. So you're going to have 3x less than, so this 1 minus 1 is going to give you 0, less than this -1 minus 1 is going to be -2. Divide by 3 both sides. You're going to have x lies between 0 because 0 divided by 3 is 0 and -2 over 3. So this is your convergence of series. This is your solution. X must lie between -2 over 3 and 0. So now 3.1.2, we want to calculate the sum to infinity of the series if x is equals to -1 over 6. So we want to find the sum to infinity. We know the sum to infinity equation. It's a over 1 minus r, right? But we know our r. Our r that we found in 3.1.1, it's 3x plus 1. So basically what's inside here, it's common ratio. We calculated it, didn't assume from the given series. So our r is equal to 3x plus 1, and we need to find our a. So our a is the first term of the series. So a in this case, it's this one here, which is 5 into 3x plus 1. So let's substitute this in our sum to infinity, because we are asked to find the sum to infinity. So when I say sum to infinity is equals to our a, which is 5 into 3x plus 1, divided by 1 minus our r, which is 3x plus 1. So this is 3. Cool. So now, but you need to remember that we were given that x is equals to -1 over 6. So meaning where we see x, we put -1 over 6. So, excuse me, so it's going to be 5 into 3 into -1 over 6 plus 1 close bracket over 1 minus into 3 into minus 1 over 6 plus 1, close bracket. So the answer that you're going to get here is going to be 5. So that is your sum to infinity. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them down in the comment section below. Otherwise, please subscribe to the channel and don't forget to click that bell button.